In problem 3.2, we are asked to match some functions with their graphs. Now what I've done here is I've moved the graphs over to the right side here so we can look back and forth a little bit easier. Now some of these functions are going to be pretty easy to match up because we've seen them before, we know what they look like, and others are going to take us a little more work to figure out. So when I look at the first two examples here, these polynomials have a lot going on. They've got, 5 terms here, we've got 3 terms here, and I don't really know what a 4th degree polynomial and a 3rd degree polynomial look like. So I'm not exactly sure which ones those match with. But when I look here at actually these middle 4 problems, these all look more familiar. So right off the bat, I can look at this problem right here, y equals negative 15. And I know that y equals negative 15. Well, that means that my y value is just always negative 15. I don't care what x is. So this actually must be graph A, because this one has a y value that is just always negative 15, right? No matter where you look, doesn't matter what x is, the y value is always negative 15. So this must be graph A. When I look at the next one, this one I know is a line that is y equals mx plus b. Well, there's only one graph over here that is a line, and that is graph C. So this must be graph C. Moving on, the next two are both quadratics. They are both x squared terms. And there's one super important difference that they have. This one has a negative out front, and this one does not, which means that that first one there must be a parabola that opens downward, which must be graph F. It's the only parabola that opens down. The fourth one must be a parabola, but it must open upward, and that leaves graph G as the only option. Now we've got 4 graphs left. We don't really know what those look like. So here's what I'm going to do. I'm going to look at these and try to just plug in some test points and see what happens. So, for example, I notice right off the bat, like 0 is a really easy point to plug in. If I plug in 0 to this graph here, 0, let's see, all of these pieces will go to 0 except for the negative 12. So this is a y-intercept of negative 12. All of the rest of these, if I plug in 0, I actually get 0 out as an answer. And you can test that out. If you plug in 0 to any of these other 3, you'll get out 0 as your end result. So that top left problem, that first one there, is the only one that has a y-intercept that's not 0, which means it must be this graph right here, graph D. There's my y-intercept of negative 12. So this one is graph D. Okay, let's keep going with this. So now 3 left, and I've got 3 graphs to match it up with. We used that one. We used that one. Let's keep crossing these off. So B, E, and H are all that are left. Now, let's check out this top right graph. I'm just going to plug in another easy number. I'm going to plug in 1. So if I plug in 1 to this problem, in this case I'm going to get 1 plus 2 minus 15, which is negative 12. So now if I plug in 1 down here, this one's going to give me, let's see, 1 minus 3, that's negative 2. And this one's going to give me, if I plug in 1, 6, 1 plus 5. So actually that should help me figure these out. So let me see, 1 comma negative 12, which is the only graph here that looks like it has 1 comma negative 12. Well, that looks like 1 comma negative 12 right there. And none of the rest of them that are left look like 1 comma negative 12. So this must be graph H. And that leaves us only with B and E left. So one of them is 1 comma 6, positive number. That's this graph right here, 1 comma 6. So that must go with this one. And that leaves only graph B left. Let's make sure it matches up. 1 comma negative 2. Well, it does. It's right there. So 1, negative 2, graph B goes with that last option there. So you can see how we can kind of match up these graphs. First, based on what we know about graphs, right? I know things are lines, I know things are parabolas, but then also just by testing some points and seeing what they look like.